Hello, grade 10 student. I am Mrs. Mina Pitumang, your teacher in mathematics. Are you familiar to the following pictures? First, we have smiley icons, number of chips in a pattern, car icons, dice faces. They are in the form of arithmetic progression. And our topic for today is about the arithmetic sequence. We have three objectives. First, we have to illustrate an arithmetic sequence, determine the arithmetic mean, the end term, the sum of the end term in an arithmetic sequence, and to solve real-life problems involving arithmetic sequence. Arithmetic sequence is also known as the arithmetic progression. Take a look at this pattern. We have 4, 11, 18, 25. So this is an example of infinite arithmetic sequence. Where 4, we have our a's of 1, 11 is our a's of 2, a's of 3 is 18, and a's of 4 is 25. They have a common number, which is you're going to add that number, then you will get the next term. In this case, we can get that fixed number by subtracting the present term to the previous term. Like 11 minus 4 is 7. 18 minus 11 is 7. 25 minus 18 is 7. And this fixed number is also known as the common difference. And that is denoted by the symbol small letter d. Therefore, our common difference is equal to 7. And our formula for that, in finding the common difference, we have a's of 2 minus a's of 1. It can be also a's of 3 minus a's of 2. Also, we have a's of 4 minus a's of 3. What if I'm asking you to find the 11th term of that given arithmetic sequence? And now I will introduce to you the first formula in this sequence. And we have a's of n is equal to a's of 1 plus quantity n minus 1 times the common difference. Where a's of n stands for our last term, a's of 1, our first term, n is the number of terms, and d is our common difference. Again, if a's of 11 is unknown, a's of 11 is unknown, given that arithmetic sequence, we can now use our n-term formula, and that is a's of n is equal to a's of 1 plus quantity n minus 1 times the common difference. Our unknown or the last term is a's of 11. Copy the formula, a's of 1 plus quantity n minus 1 times the common difference. Then substitute the given, then simplify it correctly. So we have now a's of 11 equals, your a's of 1 is equal to 4, plus n is the number of term, and that is 11 minus 1, and our common difference is 7. Simplify? By PEMDAS, simplify the number inside the open and closed parentheses. Then we have a's of 11 is equals to 4, plus what is 11 minus 1 is 10. Then multiply it by 7. So we have now a's of 11 is 4 plus what is 10 times 7 is 70. Then finally, our a's of 11 is 4 plus 70 is 74. So this will be now our a's of 11. Okay, so we have a way of checking. Writing again our given. So your first term, we have 4. Then plus your common difference is 7. What is 4 plus 7 is 11. Plus 7 is 18. Plus 7 is 25. 25 plus 7 is 32. 32 plus 7 is 39, followed by 46, plus 7 is 53, plus 7 is 60, 67, then we have 74. Okay, so this will be now our 11th term. Okay, count it from the start. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so remember in an arithmetic sequence, we have two formula. We have in finding the common difference, then the n-term formula, and that is the arithmetic sequence. And now let us proceed to arithmetic means. Arithmetic means are found between the two extremes in our arithmetic sequence. Let us solve example number 1. So we have example number 1. Insert 3 arithmetic means between 6 and 54. First, we have to illustrate our given. We have 6, our first term, followed by the 3 unknown term. Then we have the last term is 54. We can now label a sub 1 is 6, then a sub 2, a sub 3, a sub 4, and our last term is 54, which is a sub 5. We can now apply the n-term formula, and that is a sub n is equal to a sub 1 plus quantity n minus 1 times the common difference. A sub n is our last term, and that is a sub 5. So we have now a sub 5 equals copy a sub 1 plus n minus 1 times the common difference. Substitute our given, then simplify it correctly. A sub 5 is equal to 54. A sub 1 is 6 plus our n term or the number of term is 5 minus 1 times the common difference. So we can now solve our common difference by simplifying our equation. Okay, so write it again. 54 equals 6 plus, what is 5 minus 1 is 4 times d is 4d. Okay, transpose positive 6 to the left side of 54 will become now negative 6. So we have now, okay, so we have 54 minus 6 is equal to 4d. So what is 54 minus 6? 48 is equal to 4d. Okay, so you divide both equation by 4. Makakancel ang 4. We have now d, or our common difference is 48 divided by 4 is equal to 12. So we solve first our common difference, and that is equal to 12. We can now determine the 3 arithmetic means between 6 and 54. How? Your first term is 6. Your common difference is 12. Going to the right, from the first term, you will add your common difference. And what is 6 plus 12? 18. The second term is 18. Then 18 plus the common difference is 30. 30 plus 12 is how many? How many? 42. Then 42 plus 12, it makes 54, our last term. So this is on how to, okay, determine the 3 arithmetic means between 6 and 54. Another way of checking. Checking for your common difference. Okay, as I said before, when we define the common difference, you just only subtract the present term to your previous term. What is 18 minus 6? 12. What is 30 minus 18? Is 12. Okay, so that is on how you determine the arithmetic means in between the two numbers in a given arithmetic sequence. Okay, we have example number 2 under arithmetic means. Okay, so we have example number 2. Find the value of a sub 1. So we have the given arithmetic sequence. We have 3 unknown terms. Then followed by number 15. After 15, we have again 2 unknown terms. Then we have 27. We can now label the first term or the first missing term as your a sub 1, then a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, and this will be now your a sub 7, and that is 27. In this case, in finding the value of a, since you have two given numbers, where 15 is your a sub 4, 27 is your a sub 7, we let now 15 will be now your a sub 1. And we let 27 will be now your 1, 2, 3, 4. This will be now your a sub 4. Then applying again our nth term formula, and that is a sub n is equals to a sub 1 plus quantity n minus 1 times the common difference. Okay, so our last term, which is a sub 4, a sub 1, copy the formula n minus 1 times the common difference. Substitute the given, then simplify it correctly. Do not forget the PEMDAS. Okay, a sub 4 is 27 equals a sub 1 is 15 plus your n term is 4 minus 1 times the common difference is unknown. Okay, again, we can also solve the common difference by simplifying this equation. So we have 27 transpose 15, positive 15 will become now negative 15 equals, what is 4 minus 1 is 3 times d is 3d. Okay, what is 27 minus 15, and that is 12 equals 3d. Multiply equation by 3. So makakancel ang 3. So we have now the common difference is 12 divided by 3 is 4. So our common difference now is equal to 4. We can now simply find the value of a. Okay, since our common difference is 4, going to the left, you will subtract the common difference. From 15, going to the right, you will subtract your common difference again. So what is 15 minus 4? How many? 11. 11 minus 4, 7. What is 7 minus 4? Is 3. So therefore, our a sub 1 now is equal to 3. And what about the two remaining arithmetic means between 15 and 27? Okay, so this is another way. So going to the right, you will add the common difference. From 15 plus 4 is how many? 19. 19 plus 4. And that is 23. And what is 23? Plus 4. How many? 27. Okay, so that is on how you determine the arithmetic means between two numbers. Okay, so a way of checking again, getting the common difference, the percent term to the previous term. What is 7 minus 3? 4. What is 11 minus 7? 4. And so on and so forth. The arithmetic series. Arithmetic series is also the sum or getting the sum of the n term in a given arithmetic sequence. So we have the arithmetic series. Maybe you are familiar with this question. What is the sum of the first 100 counting numbers? So this is an example of finite sequence. So first we have to illustrate it. We have 1 plus 2 plus 3 plus up to the last 3 numbers out of the 100, the first 100 counting numbers, and that is plus 98, plus 99, plus 100. First step, you have to find the sum of the first term and the last term. 1 plus 100 is 101. The second term to the second last term, and that is 2 plus 99 is 101 also. And the third term to the third last term, we have 3 plus 98 is also equal to 101. So we have a formula to be used in getting the sum of this given finite sequence. So we have the sum of n is equal to, here we have a sub 1 plus quantity a sub n over 2 multiplied by n. Then substitution. Okay, so we have the unknown is the sum of the first 100 counting numbers, or the sum of n is sum of 100 equals your a sub 1 is 1 plus your a sub n, or our last term, is also equal to 100 over 2 and also is equal to 100. Okay, so we have to investigate our equation, so we can cancel 2 and 100 by 2. So 100 now will become 50. And to get 101, we have 1 plus 100 is 101. Then multiply it by 50. Then the sum of 100 is equal to the first 100 counting numbers. We have 101 times 50. So we have 0 times 1 is 0. That is also 0. 5 times 1 is 5. 5 times 0 is 0. 5 times 1 is 5. Then we have 0, 5, 0, 5. So the sum of the first 100 counting numbers is equal to 5,050. Okay, now use another formula. It is a combination of our n-term formula, and that is the sum of n is equals to n over 2. We have the open and closed bracket. We have 2 is the 1, okay, plus quantity n minus 1 times the common difference. So our n is 100, the sum of first 100 counting numbers. Okay, so we have 100 over 2. Then 2, what is our a sub 1 is 1, plus what is our n is 100 also, minus 1, and what is our common difference? 2 minus 1 is 1. 3 minus 2 is 1. So our common difference is 1. Then simplify our equation. 100 over 2 is 50. 2 times 1 is 2. Plus 100 minus 1 is 99 times 1 is 99. Okay, so we have also the sum of the second term and the second last term. We have 101. So we have 50. Then 2 plus 99 is 101. So multiply 50 times 101. We have the same answer, and that is 5,050. So this is the sum of the first 100 counting numbers. We have example 2. Find the sum of the first 10 terms of the arithmetic sequence given. Our arithmetic sequence given, we have 5, 9, 13, 17. So this is an infinite sequence. So check it first. If the common difference is a fixed number, we have to subtract the precede to the previous term. And that is 9 minus 5 is 4, 13 minus 9 is 4, 17 minus 13 is equal to 4. So this is our common difference, and that is equal to 4. So we have to use the combination of the n-term formula in getting the sum of this given arithmetic sequence, and that is the sum of 10 terms. The first 10 terms is equal to n all over 2. Okay, so we have the open and close parenthesis, 2 is of 1 plus quantity n minus 1 times the common difference. Then substitute our given. So our n is 10 over 2. 2, what is our is of 1 is 5. Plus our n term is 10. 10 minus 1. And our common difference is equal to 4. Then simplify our equation. 10 over 2 is 5. 2 times 5 is 10. Plus 10 minus 1 is 9 times 4 is, diretso na. 10 minus 1 is 9 times 4 is 36. Then this is equal to 5. What is 10 plus 36 is 46. Then finally, the sum of the first 10 terms in the given arithmetic sequence, we have 46 multiplied by 5 is equal to, that is 30 carry 3, 23. We have 230. Okay. So the sum of the first 10 terms of the given arithmetic sequence starting from 5, 9, 13, 17. What are those remaining terms? Okay, check. 5 plus 4 is 9, plus 4 is 13, plus 4 is 17, plus 4 is 21. 21 plus 4 is 25. What is 25 plus 4 is 29. 29 plus 4 is how many? 33. 33 plus 4 is how many? We have 37. Then 37 plus 4 we have 41. Getting the sum of these 10 numbers or 10 terms, and that is equal to 230. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that is equal to 230. Now let us check your understanding. Answer activity number 1. Find the missing terms in each arithmetic sequence. I'll give you 2 minutes to answer and I'll get back to you to give the answer as well right away. Okay, timer start now. Alright, time is up, and these are the correct answer. For number 1, we have 30, 39, 48. Number 2, 19, 33. Number 3, 11, 38. Number 4 is negative 2 and 22. Number 5, negative 4, 0, positive 4. Who got the correct answers? Very good. Activity number 2. The ninth term of an arithmetic sequence is 78 and each common difference is 8. What is the value of the first term? So our given are the ninth term is equal to 78, which means that the number of term is equal to 9. The common difference is 8. Is of 1 or our first term is the unknown. So we will use our n term formula, and that is a sub n is equals to a sub 1 plus quantity n minus 1 times the common difference. And for our solution, we will just substitute our given, where a sub 9 is equal to 78 is equal to a sub 1 plus the number of term is 9 minus 1 is 8 times the common difference is 8, and that is equal to 64. So we have now 78 is equals to a sub 1 plus 64. So positive 64, we will transpose it to the left side of the equal sign, and that will be 78 minus 64 is equal to a sub 1. Therefore, our a sub 1 is equal to 14. Activity number 3. Every week, Mr. Kentek increases his profit from selling cell phones by 250 pesos. His profit during the first week is 2,750 pesos. Find the profit on the 12th week. This math problem involves arithmetic sequence. How? Let us first identify what are the given values. Increases his profit from selling cell phones by 250 pesos every week represent our common difference. The 2,750 pesos profit in the first week, this will represent our A's of 1 or first term. Given this information, it will form an arithmetic sequence. The 2,750 pesos as the first term by adding 250 pesos as the common difference. Obviously, the profit of Mr. Kentek next week is 3,000 pesos. But how much he will earn in the 12th week? This means also that the value of n is equal to 12. Now, let us use the n-term formula to find the profit in the 12th week. So, by substituting our given in our formula, the profit of Mr. Kentek on the 12th week is equal to 5,500 pesos. So, another way of illustrating the arithmetic sequence we have in our problem, okay, from A's of 1 or in the first week, we have 2,750. The second week is 3,000 by adding 250 pesos every week. Up to the 12th week, we have 5,500 pesos. So this is another way of illustrating the arithmetic sequence form in our given worded problem. 250 pesos is our common difference. Are you now ready for your quiz? I will give you 3 minutes to answer this word problem. Timer start now. Time is up. Okay, let us analyze our solution. Take note that you started saving on June 15 by 20 pesos, and this will be represented as the first term, or A's of 1 is equal to 20 pesos. Then every day from then on, you saved 10 pesos more than you did in the preceding day. This statement refers to our common difference, which means that our common difference is equal to 10 pesos. On June 25, you check your savings to know how much more you need to save. But the question is, from June 15 to June 25, how many days did you save already? Let us check in the calendar. Very good. You had been saving 11 days already from June 15 to June 25, which means your n is equal to 11, or the number of terms is equal to 11. So we can now find the A sub 11. Now, let us know how much you have saved already, so that you will know how much you will need to save to have 500 pesos for the algebra book. We will use the n-term formula, and by substitution and simplify it correctly, you have saved already 120 pesos from June 15 to June 25. But how much does you still need to save to buy the algebra book that costs 500 pesos? So we can now illustrate the cost of the book is 500 pesos, minus 120 pesos you have saved already within 11 days is equal to 380 pesos. So therefore, you still need to save 380 pesos to buy that algebra book. So keep saving until you reach that amount, and surely that book will help you to understand well the beauty of algebra. Indeed, buying things coming from what you have saved is more valuable. Okay? Who got the correct answer? Very good. With these examples, I know you are ready for the next challenge. Good luck! Thank you for listening. Keep safe and God bless us all.